Welcome in. This week we're going to look at a few remaining strategies for integration involving trigonometric functions, and then also another topic with integrals called improper integrals, and specifically focusing on what we call type 1 of 3. So more on that in a later video, but we'll dive into trig integrals first. And before we get too far into those, it might be worthwhile to try and remember, okay, trig functions, there's a lot of flexibility with them. We can do a lot with our different identities, and here are some of them. And Pythagorean, double angle, half angle, angle sum and difference. See if you can write down as many of these identities as you can, and resume the video when you're ready to see all of the identities. And here are the ones that I have. So sine squared plus cosine squared equals 1, various versions thereof. Double angle identities, sine 2x would be 2 sine x, cosine x. Cosine 2x, remember that one has 3 different forms. I generally remember cosine squared minus sine squared. Half angle identities, yeah, good luck. I generally have to look it up because I forget which one has the minus. I know it's of that form, it's just one's a minus, one's a plus. And then angle sum and difference, those, remember sine, same signs, and then cosine as opposite signs. And then some other things when we are thinking about trigonometric integrals or integrals involving trig functions. Some tips. Secant and tangent, we don't do this a lot, but just if you have both odd exponents, you have to do a u substitution with secant, both even, tangent. In terms of sine and cosine, if we're looking at one of them having an odd exponent, you'd separate it into 1 plus an even number. So for example, if we had sine to the 5th of x and then cosine squared x, we would separate this into sine of x, so that'd be the 1, and then sine to the 4th x, and then cosine x. And certainly we could do u substitution with this, though we would need to convert sine to the 4th over, and then our u would be cosine. Okay, so with that idea, we have a few examples. So we'll get started on those here right now. I'll do the first, there's going to be 4 total. I'll do the first 3 with you, and then just kind of skipping steps because there's pieces that are more or less relevant. And then the last one is just for you to do on your own. I'll point you in the right direction, but I'll leave that up for you. All right, so first one, sine cubed plus, and then times cosine squared. So we kind of talked about this just a moment ago. We'd break it into like sine of x, and then sine squared of x, and then cosine squared x, all dx. Okay, convert the sine to the cosine because our u that we're going to end up using is cosine of x, which makes negative du equal to sine of x dx. Okay, so converting and then substituting, we get sine of x times 1 minus cosine squared of x, and then cosine squared of x. Oops, I'll put a parentheses there, dx. And so then when we integrate, we'd get negative integral. The dx sine x would be du. I've already pulled the u, or the negative out, and then I'd have 1 minus u squared times u squared. Okay, this is better known as, if I rewrite this, u squared minus u to the 4th du, and then as I integrate that, I get negative u cubed over 3, and then plus u to the 5th over 5 plus c, and then again, since I began in x, I need to end in x, so negative cosine to the 3rd x over 3 plus cosine to the 5th x over 5 plus c. Okay? Easy peasy, right? We've actually seen this, and we kind of had to play around with this when we did u sub stuff. moving on to the next one. So sine squared times cosine squared dx. So this one, a couple different ways to look at it. You could try and do the Pythagorean conversion, so convert sine squared to cosine, or sine squared to cosine squared. You're going to end up with a problem there if you try u sub. What I notice is that in the half angle identity, right, like if I move the 2 over to this other side, so it'd be like 1/2 sine of 2x. If I squared that side and squared this side, then I'd have the sine squared, cosine squared as I wanted, right? So actually, that's actually what I'm going to do. I'm going to say that this in here, right, it would be 1/2 of sine of 2x all squared. Okay, so then this would be integral 0 to pi over 4 of 1/4 sine squared of 2x dx. And now this is where I'm going to employ another formula. I'm going to use a half angle formula. Specifically, the one for sine, right? So I have sine squared is equal to this. Okay, so I'm going to say that the 1/4 I could actually pull out in front. So I'd have 1/4. That should be pi over 2, my bad. Integral 0 to pi over 2. And then this would be 1 minus cosine of 4x all over 2 dx. Okay? And if I wanted to, I could rewrite this as 1/4 times the quantity, integral 0 to pi over 2. And then this would be 1/2 dx minus integral 0 to pi over 2 of cosine 4x, pull the 1/2 out, dx. Okay. And if I do this, the first piece is going to give me, I'm going to let you do the integration here, x over 2, and then 1/2 of that would give us x over 8, or x over 4, I'm sorry. And then times 1/4 ends up giving us pi over 16. And then minus, cosine would integrate to sine, right? So it'd be sine of 4x, and then we would have to put in the bounds of sine of 4x, so that'd be sine of 4 times 2 pi, which would be, or sorry, pi over 2, which would be 2 pi. Sine of 2 pi is 0. Similarly, sine of 4 times 0, which is 0, so that one is just going to be minus 0. So our answer ends up being pi over 16. Okay, you can verify the calculation. Okay. Next one, tangent to the fifth, secant to the third. Okay, there's a rule about that, and the rule was what? If they're both odd, u is secant of x. Okay, so I'm going to let u be equal to secant of x. That means that du would be secant x tangent x dx. Okay, so really what I need to do is I need to kind of write this a little bit differently. This would be tangent to the fourth x, secant of x, and then times, secant squared, I'm sorry, times secant of x tangent of x dx. So all of that is going to be du, right? And then I'd have a u squared in here, which is fine. Tangent, okay, I need to convert that out. Okay, so that would be integral. I know tangent squared is secant squared of x minus 1, and I'd have to square that again. Secant squared x, and then times secant x tangent x dx. Okay, so this would be integral u squared minus 1 squared times u squared times du. Okay, writing that out, I'd get integral, expanding it and distributing and all that good stuff gives me u to the 6th minus 2u to the 4th plus u squared du. Integrating, u to the 7th over 7 minus 2u to the 5th over 5 plus u to the 3rd over 3 plus c, and then certainly resubstitute. I get secant to the 7th of x over 7 plus minus 2u to the, let's put a secant in there instead, secant to the 5th of x over 5, and then plus secant cubed x over 3 plus c. All right, and there we go. Okay. For the last one, and this is the one that I'm not going to do with you, I'm going to point you in the right direction. Both tangent and secant have even exponents, so this is where you would start with u is equal to tangent of x, and then, and then remember that du would be equal to secant squared of x dx. Okay, so you'd have to pull the secant to the 4th apart and go from there. And that is on you to do. So a little bit of a recap here on trig integrals, so integrals involving trig functions. You might have to make use of some identities, yeah? Be aware of them, be ready for them.